Hello guys. So there's a few things that I want to tell you. I haven't made a video in a while. It's week 14 has been complete now, and I just want to let you know that there's 4 more weeks of instruction that remain. And what I mean by that is today's December 7th, and we have 2 more weeks before we have our winter break. And then after that, we come back. We have Thursday and Friday, and then we have 2 more weeks until Regents Week. So our last day of the semester is January 17th, and then we have a new semester that starts January 28th. So what I want to say is if you're happy with your grade, keep doing what you're doing. And if you're unhappy with your grade, check pupil path. Always check pupil path. You will find if you need any homeworks, you're missing any homeworks, or you have any incomplete labs that you need to make up, you need to do that in the next 4 weeks of instructional time. So take care of that. You know what you need to do, and it's up to you to make that happen. So this week, on Monday, we completed a convection current lab. I want to show you again what convection currents look like. Okay, you have a heat source in the middle, and that would be analogous to the core. And then you have mantle. In this case, we're showing oil and some flakes of mylar here. We tried to do it with flakes of oregano, just showing that the mantle is moving in this convection kind of cell manner, in these circular movements. And that convection of so this is convection of the asthenosphere. That is what's going on inside the asthenosphere, the top of the mantle, and that is moving the lithospheric plates, or moving the crust. All right, another thing that we did this week was we talked about the interior of the Earth. We started doing that by looking at page 10, the inferred properties of Earth's interior in your Earth Science reference table. Now, what it's showing is density of the Earth through the different layers. It's showing the different types of plate configurations in this area. It's showing pressure in this part of the graph. So it's its own separate graph showing at depth the pressure increases. And the temperature is this third part of it. Temperature and the depth increasing as you go deeper into the Earth. So the properties that you see are 3: density, pressure, and temperature. So then we looked at the evidence for how the Earth's structure is in these layers. And what the evidence are several. There's 5 of them that we went over. Density, seismic waves, volcanoes, Earth is a magnet, and meteorites. So we had a density of liquids lab earlier in this unit, and really what the structure was, what it was trying to show is a model of how the Earth is layered, with the inner core as the most dense material, which was our corn syrup. The outer core was analogous to dishwashing liquid. The asthenosphere, stiffer mantle, was then water, and the crust is then the oil, the vegetable oil that we used. So that was a physical model trying to get at what is going on with density as a property. And so the main thing about density is that it's based on gravity, or the force of gravity, bringing that more dense material to the center of the Earth. What are the most dense elements that make up the Earth? Where are they located? Iron and nickel, located in the inner and outer core. And that is also on page 10 of your reference table. We looked at evidence of number 2 was seismic waves. It's probably the most important piece of evidence that shows the structure of the Earth, and I'll show you a little part of the video that I showed in class.
Using seismic waves, we've been able to construct a journey to the center of the Earth. Peel back the crust and there's a solid mantle. Under the hard mantle, there's a very hot liquid core. At the center, we find the inner core, which is solid. A remarkable discovery considering we've only drilled 12 kilometers into the crust.
P waves travel through the interior of the Earth. They start from the point where the earthquake happened and then dive deep into the Earth. And as you can see, they get deflected by the changing structure inside the Earth.
Inside the Earth, there is a boundary that bends the P waves. And this boundary is between the solid mantle and the liquid core.
Just as light waves get bent when they change from air to water, the earthquake waves get strongly bent when they go from solid to liquid.
Evidence number 3 is volcanoes, and here are some volcanoes that I showed in class. What I want you to notice is that this is very hot material. It's at least 1100 degrees Celsius. Volcanic material is everywhere. On Earth, it's the most common crustal material. It flows freely from divergent plate boundaries, so there's a lot of it, and it's coming from somewhere, and it's coming from the asthenosphere, essentially. Earth is a magnet, so Earth has a magnetic field. Earth has a magnetic field that repels solar winds to help us maintain our atmosphere. Our atmosphere isn't blown away like the two planets that are closer to the sun. And it is essentially like a magnet that we used in elementary school, where north is up and south is down. And that is indicative of Earth's core, or Earth's main material in the inner and outer core is iron. And lastly, meteorites. Evidence number 5 is meteorites. Meteorites are extremely dense. We find them around on the surface of the Earth, but as individual pieces. This is a large piece, a large meteorite that was found in Arizona, and it's in the American Museum of Natural History. It's taller than a human. It's huge and extremely heavy because it's extremely dense. And that material is made up of iron and other elements that aren't created at the surface of the Earth. And this is the Barrington crater in Arizona that was likely created from a meteorite, probably between the hand size that you saw in the beginning and this larger one that's at the museum. We also talked about hotspot volcanism. It was one of the topics that was in a reading I gave out about volcanoes. Here we're showing hotspot volcanism as lithospheric plate. The plate is moving over the hotspot, and the hotspot, known as a mantle plume as well, is stationary, meaning it does not move. And this is analogous to the Hawaiian Islands. So on Monday, we will do another lab on Hawaiian volcanism and the Hawaiian hotspot. We had some homework. We had an assignment. We had a lab. We took some notes. So the homework and the assignments will be linked to in the Google Classroom. That was Interior of the Earth, a reading on the interior of the Earth. It was also a written way. There was a write-up on how to use page 10 of the reference table. We did a getting to know the ESRT, Interior of the Earth, page 10. That was an assignment. And there was a reading on volcanoes. So those are all due, those are all required, and they're linked to in the Google Classroom. Finally, I'll bring in some index cards. I said I would do that. I will do that. I'm going to bring in index cards on Monday. I'll give some out for those who need, and it sounded like everybody needed. So we will continue to have earth science related vocabulary. That is going to be what we do the rest of the year. So we really need to come to terms with learning the vocabulary. We'll continue to be quizzed on those vocabulary terms, and they will all come in handy in this class and in June when you take the Regents exam. So I'll see you Monday. Have a great weekend.